Hello everyone, and I welcome you all to another video of our stack series. And in the previous video, we learned about implementation of a stack using array. Alright, and in this video, we are going to learn about implementation of a stack using a linked list. Alright, so I hope like you remember what is a stack. Stack is basically a data structure which follows the LIFO order, which is last in first out. Alright. And I also hope you remember what is a linked list. So linked list is basically a data structure which contains nodes, and every node contains two things: data and address of the node it is pointing to. All right. So this is the basic stuff. You should be knowing it. Okay. So we have to like implement stack using a linked list, and here are the functions which we have to implement. So we have to implement the push function, we have to implement the pop function, we have to implement the isEmpty, size, and top. So we know what is a push function. It pushes a value inside a stack. Pop removes the top element. IsEmpty tells us whether the stack is empty or not. Size tells the size of the stack, and top gives us the top element of the stack. All right. So suppose my stack contains 5, 10, and 15. Alright. So my linked list which is implementing the stack should look like this. Alright. Yes. Now if I say if you remember in our linked list we always have the head pointer with us. So if I say I have to add an element here, suppose if I have to add 20. Suppose if I have to add 20. So what I'm going to do, I have to like traverse this linked list till the end, and then I'll add 20 here. So the traversal will take big O of n time, right? But I already told you that we have to do all these functions in big O of 1 time. So a better solution would be to make our stack look like this. Just give me a minute. Alright, 15, 10, and 5, right? So if I have to add an element here, we'll like suppose I have to add 20. So I'll simply create a node of 20. 20 is going to point here, and then head will point here. Alright. And similarly if I have to like remove this 15, what I'll do, I'll simply increment the head here. So all this is going to take big of one time. So we have to like add every element, new element at the head in the beginning of the linked list. Alright. So now without any delay, let's try and code this, and after that we'll do a dry run. Let me increase the size a bit. Okay. Let's include our header file. My bad, 1 minute. Alright. So if you remember, we have to make a structure of our linked list. So let's make the structure of our linked list. Right, it is going to contain data, and it is going to contain a next node. Alright, and if I say node index, data is going to be x, and next is going to be null. Alright, so this is the basic linked list creation code, which we have already discussed in the linked list series. So I'm not going deep into this thing. Now, let's write our my stack, which is our stack structure. All right. So let's have the head here, and let's have the size, which will contain the size. And let's uh, make the constructor for it. Initially, size is going to be 0 and head is going to be null in our constructor. All right. Now let's write a push function. So suppose I have to write a push function. It is int x. So I'll make a node star temp is equal to new node x. All right. Now I have to insert this in the beginning. So what I'll simply do temp next is equal to head, and head is equal to temp. Alright, and I'm going to increase the size. Now what I'm going to do is I'm going to write the int pop function, which will pop the top element and will give us what is the top element. Okay, so what we can do is, if head is equal to null, that means there's no element, so we don't have anything to pop out, so we'll just write cout empty. All right, and what we can do is we'll have int res, which will contain the head data. All right, and I'm going to have node star temp equal to head. All right, and I'm just going to do head as head next, and then I'll simply delete our temp. That makes sense. I'll decrement the size and I'll simply return our res. All right. If I write, if I have to write int top, it is going to give me the value of the top element of a stack. Our top element would be basically the value stored in our head of our linked list. Right. So I just simply do return head data. Cool. Now if I write about int size, so it will simply be return size. Alright, and if I have to write the function bool empty, so if what I'll simply return head is equal to null. Cool. So I have written all the functions: void push, int pop, int top, int size, and bool empty. Okay. Now I'll write int main, and here what I'm going to do is simply make my stack object s. Alright, and simply I'm going to push 5. Let me close this thing so we'll have more space here. Alright, then I'm going to push 10, then I'm going to push 20. Okay, now I'll simply write cout s dot pop end. I'm going to write cout s dot size, Alright, and I'm going to write s dot top, and I'm going to simply write s dot empty. Okay, let's try and run this code. Okay, so our answer is 20 to 10 0. Now let's have a dry run to see whether what we got is right or not. Okay, so here we have our okay. Okay, I cannot make the right line straight. Um, Give me one more time and okay, this would work. So if I see here in my stack, currently my according to my constructor, my head is going to be null and size is going to be 0. Alright, so size is what? 0 and head is equal to null. Alright, now what I am going to do is I am doing s dot push as 5. Alright, so if I write my linked list, it would look something like this, pointing to null. And here I'll have an element 5. Now what will happen? I'm going to push 10. So 10 would come here, right? And I'll push 10 here. And this is going to be my head. Now what will happen? I'm going to push 20 here. So I'm going to push 20. And 20 will come here. And head will point towards here. And size would become 3. For every insertion, our size is also going to increment. So we increment as we inserted 3 times, so our size would increment by 3. Okay, cool. Now I'm doing s dot pop. So in pop, what we are doing exactly, we are returning the top element or head in our linked list and deleting the head. So that means we should get the output as 20. Okay, removing this element from here, making this as our head and decrementing size by 1, so size would become 2. Cool. Now what we have here is we have to return the size, so we'll simply return the this as z, so we'll get 2. Then we have to tell the top element basically is going to be top element here, which is going to be head, this one, so we'll get 10 here. And next is whether it is empty or not. So our stack would be empty when our head is going to point towards null, so our head is not pointing towards null, so we'll get the output as 0. So we should get this as our output. To cross check, let's see. Okay, what is the problem here? Twenty-two ten zero, the same output. Alright, so I guess that was it for this video where we implemented a stack using our linked list. So we have learned about implementing a stack using array as well as our linked list, and in the next video we are going to talk about C++ STL, which is standard template libraries. It has its own stack class and related functions, so we'll talk about it in the next video. So thank you for watching this video, and if you have any doubt regarding it, you can put it in the comment section. So thank you and see you later.